In this video, we're going to go through the topical 10 series on DC circuit. Now let's start with question number 1, and question number 1 I have to say is a bit tedious, okay, but let's go through step by step. Now you're given that a variable resistor and a light bulb here, they are connected in series, and it's given that the brightness of the lamp increases. Now one thing to take note is power. The brightness depends on power, and power, you know, is equals to IV. That means to say the current, either the current increases or the potential difference across the bulb increases, or both increases. But if you just treat it simply, since the brightness increase, that means to say I definitely has to reduce the resistance of the variable resistor. Okay, I reduce it, then the total effective resistance for the whole circuit, which is because they are connected in series, so the total effective resistance, you just need to add them up. So the total resistance will decrease, and therefore the current flowing through the circuit, through the bulb or through the variable resistor, will have to increase. So from here, you know that the lamp definitely will have an increase in the current. Anyway, if it's brighter, definitely the current is higher, okay, cannot be decreased. So the next thing I need to know, which is a bit complicated, is the voltage across the variable resistor. In other words, I put a voltmeter across the variable resistor to measure. Now a bit tricky, because if you were to look just solely on the potential difference across the variable resistor, and you'll be using the formula V equals to IR of the variable resistor, just now we already established that the current flowing through the circuit is going to be higher, but you reduce the resistance of the variable resistor. Now if one increase, you can see that here, one increase, one decreases, it's very difficult to convince yourself whether the voltage or the potential difference across the variable resistor should increase or decrease. So that means we cannot use this approach. So we should be using we can use the bulb here. The potential difference across the bulb equals to IR, and as you know, bulb is a non-ohmic conductor. That means to say the VI graph will actually looks like this. Okay, so as the current increases, the temperature of the bulb increases, and the resistance of the bulb will shoot up, okay, will increase. It will not stay constant. So that means to say the resistance of the bulb increases, and earlier on we said that the current increases. So that means to say the potential difference across the bulb will increase. So having said that, so you understand that because the variable resistor, the sum of potential difference across the variable resistor, that means V plus the potential difference across the bulb, must be equals to the EMF. In this case, the EMF, the battery, you do not change, so this is constant. So we already established that the potential difference across the bulb is going to be higher. That means to say this has to be lower, so this will decrease. So the answer is B. Next, for question number 2, you are given 3 identical bulbs, and it's connected to a cell here. So conventional current will flow, and it will split, and then it will join back, and that's why you will know that P is the brightest, and Q and R will be dimmer, but they are equally bright. All right, but this question here, they say that a copper wire, for our syllabus we can treat it as copper wire has basically very low or no resistance. So it's connected between S and T. So that means to say this copper wire is connected to this two, so it has no resistance. So basically it's a short circuit path. That means to say all the current will choose to flow through from T to S via this by this low resistance path. So Q and R will basically be useless. They are redundant now. So only P will light up, and P will be brighter than just now, because right now if you take a look at this, because Q and R, they are redundant, so basically this whole circuit is only left with your P, and the total resistance of the whole circuit compared to just now will be lower, so the current will be higher, therefore it will be brighter. Okay, so Q and R will go out while P will become brighter, so the answer is A. Question 3 here, you can actually basically redraw the circuit. This is the EMF of 12 volt, so that means to say this is the fixed resistor here, and the potential difference across here is 6 volt. Then it will split into two smaller branches, and this is your R, and the current flowing through in this branch is your 1 ampere, and finally it goes back to the battery, and this current here is 3 ampere. Now if you understand the reverse system, you will know that this 3 ampere is the main current, and everywhere along here until this point will be 3 ampere. That's the big river, and when it comes to this junction here, it will split into two smaller river, and it's given that this is 1 ampere. So that means to say the current flowing through here, that means 3 minus 1, that will be your 2 ampere current flowing through in this branch. Alright, so if we know that, another thing we need to know now is because this 6 volt here, this resistor is in series with these two. Of course, these two are in parallel. So what I know is because the potential difference across here is 6 volt, that means to say the potential difference across here, which is in series, has to be 12 minus 6, which is 6 volt also. Okay, because the rule is the sum of potential difference across these two in series has to be equals to the EMF. If you know that this is 6 volt, I can find the resistance R here, because R equals to V over I. The V across the R is 6 volt, and the current flowing through, which we have found just now, is 2 ampere. Therefore, the resistance of R will be 3.0 ohms. So the answer will be B. Next, for question number 4 here. Alright, now if I were to simplify the diagram, I can redraw it into, this is the main river IT, and this is in this branch there's only a 3 ohms resistor, and this is the 2 ohms resistor and 4 ohms. I can further simplify this into two branches, 3 ohms. Alright, and this one, because these two are in series, so effectively I can just sum them up. That will be your 6 ohm resistor. Now to do this question, you can actually, based on understanding, there's no need for you to do calculation. So it is given that the current flowing through this branch is 3 ampere. Now if you think about it, in this branch, the resistance, the traffic jam is only 3 ohms, and the current flowing through is 3 ampere. And if you compare it to the other branch here, the other branch, it has double the resistance, double the traffic jam here, which is 6 ohms. So obviously the current flowing through here will be lesser, and in fact it will be half. Alright, so you will know that this current here will be 1.5 ampere. If you know that here is 3 ampere and here is 1.5, they will combine back to form the main current, which is your IT, which is the same here. So IT will be 1.5 plus 3 ampere, that will be 4.5 ampere. So either B or C is correct. Now the next thing I need to find is the V here, which is you're basically finding the EMF of the battery. Now, so there are a few ways of doing. You can also see it as, because these two are parallel, the V, the potential difference here, and the potential difference here will be the same. And since they are connected parallel to the battery, nothing else really, so this V here must be equals to the V here, must be equals to the V here. So I can just take any one of here to find the V. V across the 6 ohm resistor equals to IR, and we know that the current is 1.5 and the resistor is 6. So that will be your 9 volt. Or likewise, if I want to use this one, it will get the same result. IR, and the current flowing through this branch is 3 ampere and the resistance is 3, so it's 9 volt. That means to say here is 9, here is 0. So the potential difference will be, the EMF will be 9. So the answer will be B. Now for question 5, you have two resistors that are connected in parallel. So this is the 2 ohms and this is the 5 ohms. They are connected in parallel to a power source here. And which of the following is correct? Now the current from the power source, which is here the main current, is the sum of the current in each branch. That means the big current comes to here, it will have a choice of 2 ways to go, it will split into 2. So that is correct. But nonetheless, let's take a look at the other options. The current in the single branch may be found by taking the resistance divided by the potential difference. That's wrong. If you want to find current, that should be potential difference V over R, not R over V. So that's wrong. The current is equal in both branches. Now, definitely not true unless the current will split equally in this branch and in this branch. Unless both resistors here are the same, then they will split equally. But since, and you should know that since this branch, the resistance, the traffic jam is lower, more current will flow through here, less current will flow through here. So definitely they are not equal. And the sum of potential difference across each resistor is equals to the EMF. That is only true unless if these two are connected in series. The V here plus the V here is equals to the EMF. But for this case, you should know that they are parallel. The potential difference across the 2 ohm resistor and the potential across the 5 ohm resistor, they are the same. And since they are parallel to the battery, so the EMF will be equal, okay, not the sum. For question number 6 here, take a look here. So this is very simple. Basically, to find total effective resistance, I will just apply the formula 1 over 4 plus 1 over 2 plus 1 over 1 to the power minus 1. Remember to invert back and you get the answer 0.571. So round off is 0.57 ohms. So the answer is B for this. Next, for question number 7 here, you have a simple DC circuit and you know that so the current flowing through here, they are the same, and that's the big current, the main current. Only when it comes to here, it will split into 2. Alright, since it's given that the resistance of X, Y, Z, they are equal, so the current will split equally between Y and Z. So you know that the current flowing through X is the maximum, that's for sure, and it will be, the relationship between here will be Ix equals to Iy plus Iz. These are the rules that you know, and of course Iz will be greater than Iy, Ix will be greater than Iz also, and of course Iy must be equals to Iz for this case because both the resistance are the same. So if you understand this, you just look at the statement here. Just be very careful. So the current in Y is larger, definitely wrong. So the current in Y is smaller than X, so it's either C or D. And we already know that the current in Y has to be equals to the current in Z. So the answer is C. Next, for question number 8 here, there are 2 ways, and let me just show you the easier way. If I want to find the current in the ammeter, you know that that is basically the main current. So the first step I need to do is to find the total effective resistance for the 6 ohms and the 3 ohms connected in parallel. So Re is equals to 1 over 6 plus 1 over 3 to the power minus 1. And if you work it out, it will be 2 ohms. That's the total resistance for the whole circuit. So then I can find the current flowing through the ammeter, which is the main current, V over R. If I use the EMF, which is 12 volt, alright, I must use the total effective resistance. So you can see that the current flowing through is 6 ampere. So the answer is D. Now, of course, just to show you, I can also find the individual current because these two are connected in parallel, you know that the V and the V here must be the same. And since they are parallel to the battery, so that means to say this is also 12 volt, this is also 12 volt. So what's the current flowing through the 6 ohm resistor? V over R. The V across the 6 ohm resistor is 12 and the resistor is 6, therefore it's 2 ampere in this branch. And likewise, you do the same for the other branch, the 3 ohms resistor. It is still 12 volt and the resistance in this branch now is only 3, so it's 4 ampere. So this is 2 ampere and the small river 4 ampere, they combine back to form the big river. So the current flowing through the ammeter will be 4 plus 2 equals to 6. So either way, you'll get the answer. Next, question 9. So there are 4 bulbs here and it's given that one of the bulb, the filament melts, okay, that means it's blown. The other 3 stays on, so it can still work. So which lamp will the filament melt? So if you look at it, as long as it can form a closed circuit, okay, that means this bulb, and D will light up. 3 are lighted up and only B is the one that is blown. So B is the one that the filament melts. And for question number 10, well, it's similar also. So a few things I need you to know based on the rules. The current R is equals to the current in S. This is what you know because the current in that branch, there's only one path, so it's the same. And if you look at this branch versus this is 10 ohms resistance. The traffic jam is actually half of this. In this road here, this branch here, the resistance is double. So that means to say the current flowing through here will be much higher, will be rather just double of this. So you know that the current flowing through Q has to be greater than the current flowing through R. And remember, this is a big river, then it's split into Q and R. So the relationship is P, the current in P is equals to Q plus R. And you also know that your P will be the maximum because P is the main current. So let's take a look here. So the answer is A because P is greater than Q, that's correct. So the rest, if you look through the understanding here, all these are wrong. Now for question number 11, it is slightly more difficult. And let me draw this out first. So initially the voltage, that means the EMF is across the resistance R here and versus another setup which is double the voltage. Alright, that means the EMF is double, so it becomes 2V and it's the same resistor here R. So you're going to compare what happens to the power of the resistor when the voltage across it is double. So you can treat it this way. And just to recap, you have learned the formula V equals to IR and power equals to IV. And I told you if you combine these two, I'll be having power equals to I squared R and also power equals to V squared over R. So in this case, which one will I use? Okay, I will not use this because as you know, the current will be different, the V will be different. So there are two things that are changing. So a bit difficult for me to relate. So likewise, the current will be different. I won't be using this. It will be best to use this. Why? Because the resistance is constant. So in other words, you know that your power is just directly proportional to the potential difference across the resistance. In this case, it's like the EMF is double. So if this is the original power P when the potential difference is V, so if my new power for this resistor now across this resistor is because the voltage is double, the whole thing square, it will be 4V squared. Since V squared is the original P, so in other words, the power actually increases by 4 times. So the answer is C. Next, so what is the effective resistance? So this is the same. The answer will be A. You can actually refer to question number 6 earlier on. And next one, question number 13. Now, likewise, this kind of question is quite common. This is the big river. The current A1 is the same everywhere here. Even the current flowing through the battery is also A1. When it comes to here, it will split equally, not equally, it will split into two smaller river. And you know that a few things you must know, because this resistance is 2 ohms and this is double the resistance, double the traffic jam. So the current flowing through A2 has to be greater than the current flowing through the A3. And also, because you understand the river system, the main river A1 is equals to your A2 plus A3, and A1 is the maximum. So if you understand this, let's take a look at maybe this relationship. All right, so A2 plus A3, which is A2 plus A3 here, it has to be equals to your A1. So for this case, if you take a look at this, A2 plus A3, the total is 2 ampere, which is not equals to A1. So this is wrong. Likewise for this will get 4.5 ampere, but the A1 is not 4.5, so this is wrong also. So now the next one, 1.5 plus 3 is 4.5, so these two are possible. But then, like in the previous question, you know that A2, because it has lower resistance, the A2, the current here has to be greater. So A2 must be greater than A3, and the total is 4.5, so the answer is D. So without doing calculation, you can actually work it out. Now for those who want to do the calculation just to prove or double check, of course you can find the current flowing through A2. You know that these two, the V here has to be 6 volt, the V here across here is 6 volt because the EMF is 6 volt here in this case. So V over R, 6 divided by 2, that will be 3 ampere. And the current flowing through here across A3 will be V over R, 6 divided by 4, 1.5 ampere. So the current flowing through A1, the big river, will be 1.5 plus 3 is 4.5 ampere. You can do this kind of calculation to prove to yourself. Okay, that's all for the MCQ. If you are unsure, just look through again the video. All right, thank you.